Okay, so now very much piggybacking off of problem 8, what we're going to do is we kind of are just switching out some of these different numbers here. Okay, so we're not gonna compute both of these. We're just gonna compute one of them. I'm gonna show you how to do this in R in a moment here. We're gonna do kind of just one half of each of these problems, and we're gonna do them together. So I'm gonna kind of do the part of computing the first part of problem 9a by hand, and then the problem 9b by hand, and then we're going to switch over and look at this in R. Okay, so based on what we talked about at the end of the last problem, we just get to switch things up. So the probability that we get exactly 30 heads with coins in A is going to be, okay, well, first off, we're just doing the combinatorics. So we're flipping 300 coins, and we want 30 of them to be heads, times 0.1 to the power of 30, because that's the probability of getting heads, and then 0.9, and how many tails will we have? Well, it's going to be 300 minus 30. It's going to be 270 coins. I'm writing it in this way in particular. So what we can do is, we'll see in a moment how to do this. We can type this into R, and we can get some number. We can do the analogous thing, but now the probabilities are 0.5, and the number of heads is 150, and we can compare those two probabilities. Okay, in problem B, we have something sort of essentially similar somehow. We have that we're flipping 300 coins, same scenario, land on heads with probability 0.1, same scenario. And we want to know now the probability of not just getting 30 coins, but getting 30 heads, but getting 30 or more heads. Right, so I really want to emphasize that. So here's how I want to think about this. The probability of getting 30 or more heads, let's copy this down. Probability of getting 30 or more heads greater than or equal to 30 heads is going to be equal to, well, this is the probability of getting 30 heads. Or what we could do is we could get 31 heads. So let's change all of these 30s to 31. Or we could get 32 or 33 all of the way up to 300. That's going to be 300 choose 300, which that binomial coefficient equals 1. And then it's going to be 0.1 to the power of 300, which is basically 0, times 0.9 to the 300 minus 300. Right. This is astonishingly small. There's like basically no world in which we get all heads here. Okay, and now all I want to do is I want to put this thing into R and see if we can figure out the probability of getting greater than or equal to 30 heads. Okay, now here we are in RStudio, and what I want to do is I want to write a function which is going to compute the probability. So let's call this compute probability. And it's going to be a function which, let's have it take a bunch of different things. Let's have it take n, which is the number of coins, k, which is sort of the number of heads, p, which is the probability of getting a head. And then what we're going to do is, the way that we type that binomial coefficient is it's going to be choose n comma k times that probability to the power of the number of heads that we're getting. And then we're going to have 1 minus the probability to the power of n minus k. So that's the number of tails that we're getting. Okay. So I'm gonna run this. Down here it's going to say, great, I got it. And then let's just check that it matches our intuition from problem 8. Right, so in problem 8, we had compute the probability where we had 3 coins, and we had, say, 2 heads, and we had the probability of getting a head was 0.1. And what did we get for that? Well, down here in the console here, I'm going to write what we computed, which was 3 times 0.1 squared times 0.9. And great, so we match. So we feel reasonably confident that this function's working. Okay. And now what I'm going to do is I'm just going to compute the probability for the 300 coin case with 30 heads, where we have a 10% chance of getting a head. And when I run this, we're going to get that there's about a 7.7% chance that we get exactly 30 heads. Now, one thing that we can do here is we can kind of run this for a bunch of different values. We can compute the probability from 30 up to 300. And when we do this, we're going to get a big, long vector. The first thing in the vector is going to be the probability of getting exactly 30. So that's what it is. And then the probability of getting exactly 31 is a little smaller, and exactly 32 is a little smaller. And you can see this is sort of 10 to the negative 2. Once we get down here, it becomes like 10 to the negative 100, that we get lots, and exactly 100 or something like this. Okay, and now what I'm going to do is I'm just going to sum these up, and I get that the probability of getting 30 or more is 52.8. Now, the way that I would do it for the other part, now that we're basically here, for part B on problem 9b, the second part is that we wanted to know getting 150 or more heads, and the probability of getting heads is 0.5. And when we run that, we get, oh, that's something essentially similar, very similar. The probability of getting more than 150 or more heads is slightly less likely than the probability of getting 30 or more in the biased coin case. So remember, this one's this is for the biased coin, and then the second one here is for the fair coin.